Welcome back to another explainer. Okay, today we are looking at something pretty fascinating. On the surface, the source document we're analyzing is just a university syllabus for ESL 205 Java Programming Lab. But if you read between the lines, it's actually this carefully curated simulation of a real-world software development lifecycle. Whether you're just learning to code or you're managing an entire engineering team, understanding this progression is absolutely key to realizing what it truly takes to build robust software. Over the course of this explainer, we're going to see exactly how this curriculum takes a complete novice and, step by step, transforms them into a developer capable of launching a robust, fully graphical application. All right, let's dive right into this.
Here's our roadmap for today. We're going to hit the course blueprint, lay down the foundations of Java, explore object-oriented architecture, dive into robustness and multi-threading, build some graphical interfaces, and wrap it all up with projects and evaluations. Kicking things off with Section 1, the course blueprint.
So the total time commitment here? Exactly 60 hours of dedicated lab time. And within that window, students are challenged to build at least 12 practical experiments. This isn't just about sitting back and absorbing theory, right? It's about getting hands-on keyboard time. It's about building up that crucial coding muscle memory.
And it's a 100-mark quest that's split perfectly down the middle. You've got 50 marks tied up in continuous in-semester assessment. So that's your term work, your daily logic building, and active participation. Then the other 50 marks, those are locked behind the high-stakes end-semester practical and oral exam. The big takeaway here is that daily consistency is rewarded just as heavily as that final clutch performance.
Moving right along to Section 2, Foundations of Java.
So Module 1 dedicates 11 full hours strictly to fundamental programming tokens. You know, before you can build a house, you've got to know how to swing a hammer. Here, the learner gets geared up to handle command line arguments, basic data types, operators, flow control statements like your ifs and while loops, plus 1- and 2-dimensional data arrays. It sets the absolute foundation for everything else to come.
Now, what's really cool is how the course supplies all those basics right away. Instead of just doing disconnected, random homework assignments, the syllabus introduces this core cohesive theme, an ongoing inventory management system. It kicks off with 3 initial steps. First up, writing code to accept a store name via the command line. Second, using conditional statements to check if stock is out, low, or available. And third, using arrays to calculate the total and average stock across 5 different products. So right out of the gate, they are tackling actual operational business problems.
Which brings us to Section 3, Object-Oriented Architecture.
A massive milestone in this phase is encapsulation. The syllabus explicitly mandates creating a product class with private attributes. Think about it. In a real-world app, you absolutely do not want anyone accidentally overriding a product ID or a price. Encapsulation teaches developers to securely hide those sensitive attributes behind controlled access points, specifically using public getter and setter methods. It's all about baking data security and reliability right into the structure.
Let's look at how this actually plays out chronologically. By hour 12, they've built that basic, encapsulated product class. Fast forward to hour 20, and they're diving into inheritance, extending that base class to create a specialized electronic product that tracks extra stuff like brand and warranty period. And then by hour 30, they're implementing interfaces to modularize operations, like adding or removing stock. They are literally architecting scalable inventory software piece by piece.
All right, stepping into Section 4, Robustness and Multi-Threading. Module 4 is all about introducing the safety nets. Let's face it, users are totally unpredictable. They'll type in letters when you ask for numbers, or they'll try to enter negative prices. Task 10 specifically tasks students with using try, catch, and finally blocks to gracefully handle those exact kinds of invalid inputs. This is exactly how everyday code evolves into industrial-grade, crash-resistant software.
And then we hit multi-threading. This is a brilliant illustration of real-world multitasking. Modern software obviously doesn't just do one thing at a time. So the syllabus challenges students to write a Java program where one thread is actively updating product stock, while a totally separate thread is simultaneously generating an inventory report in the background. It is a huge leap in logic and operational efficiency.
Next up is Section 5, Building Graphical Interfaces.
You know, one of the primary objectives of the whole course is bridging that gap between the machine and the human user. The curriculum dedicates an impressive 16 full hours strictly to transforming this text-based backend they've been building into a fully visual application.
By the time they hit task 12, which is kind of the culmination of their lab work, students are actively using Java Swing components. They're throwing down JFrames, adding text fields, dropping in buttons, and writing action listeners to actually do something when a user clicks those buttons. They are building a functional graphical user interface for that exact same inventory project they kicked off way back in week 1. It is such a huge payoff.
Finally, we arrive at Section 6, Projects and Evaluations.
The evaluation here is intensely practical. Those 50 in-semester marks, they're earned by verifying outputs, writing structured programs, squashing syntax errors, and pulling off a collaborative 15-mark capstone project. Meanwhile, the 50 end-semester marks demand live, on-the-spot task execution for a totally new problem, alongside an oral viva. Seriously, there is nowhere to hide if you didn't write the code yourself.
And what about that 15-mark capstone project? Well, groups of 3 to 4 students get to choose from some pretty neat real-world applications. We're talking a mini banking system for deposits, a bus reservation system, or even a medical store management system. They've got to design the app, implement all those Java concepts, build out the GUI, and then actually stand up and defend their logic in a Viva. They literally have to prove they can deliver a complete working software solution from scratch.
We're going to wrap up on this really provocative thought, pulled directly from the performance indicators in the syllabus. Indicator 11.2.2 asks the student to recognize the need for lifelong learning. It is honestly the perfect question to ask at the end of a journey like this. Since technology is constantly evolving, and the tools we use today might be completely obsolete tomorrow, how will you ensure your learning continues long after these 60 hours are up? Because at the end of the day, that is the true mark of a developer. Thanks for hanging out with me for this explainer, and keep learning.